a stunning expression involving powers of complex number. If z is equal to root 3 by 2 plus I by 2, where I is root of minus 1, can you simplify 1 plus iz plus z to the power of 5 plus iz to the power of 8 whole to the power of 9? This JEE 2019 question tests your understanding of Euler's form and complex powers. Let us decode it the smart way. It is given that z is equal to root 3 by 2 plus 1 by 2 into I. When we express this z in polar form, we get cos pi by 6 plus I sin pi by 6. In the exponential form, it is e to the power of I into pi by 6. We are supposed to simplify 1 plus iz plus z to the power of 5 plus iz to the power of 8 whole to the power of 9. For that, let us evaluate the term by term of the base first, so that I will consider iz. Iz is nothing but I into e to the power of I into pi by 6, because z is equal to e to the power of I pi by 6. When you express I in the polar form, it is cos pi by 2 plus I sin pi by 2. But in the Euler form or in exponential form, it is e to the power of I into pi by 2. That is, I is nothing but e to the power of I into pi by 2, or this is cos pi by 2 plus I sin pi by 2. Now, when you apply this law of indices, you get e to the power of I into pi by 2 plus pi by 6, which is equal to e to the power of I into 2 pi by 3. This can be handled in a different way also, like multiplying a complex number by iota or I rotates it by 90 degrees anti-clockwise. So if z is equal to e to the power of I theta, then iz becomes e to the power of I into theta plus pi by 2. Therefore iz is nothing but e to the power of I into pi by 2 plus pi by 6, where theta is pi by 6 here. So directly iz can be written as e to the power of I into pi by 2 plus pi by 6 also. Now upon simplification, we get e to the power of I into 2 pi by 3. Next, let us express this in polar form, so that we get cos 2 pi by 3 plus I sin 2 pi by 3. We know cos 2 pi by 3 means minus 1 by 2. In the second quadrant, it is cos of pi minus pi by 3, which is minus cos pi by 3, that is minus 1 by 2. Similarly, sin 2 pi by 3, sin is positive in second quadrant, that is sin of pi minus pi by 3 is sin pi by 3, which is root 3 by 2. Therefore iz is nothing but minus 1 by 2 plus I into root 3 by 2 in a plus ib form or rectangular form. Next, let us consider z to the power of 5. Z to the power of 5 is nothing but e to the power of I pi by 6 whole to the power of 5, because z is e to the power of I into pi by 6. Then this is in the form of a to the power of m whole to the power of n, which is e to the power of I into 5 pi by 6. Next, express this in polar form, so that we get cos of 5 pi by 6 plus I sin of 5 pi by 6. This is nothing but pi minus pi by 6. That is 6 pi minus pi by 6 is 5 pi by 6, which is in second quadrant again. In the second quadrant, cos is negative. This is minus cos pi by 6, which is nothing but minus root 3 by 2. Similarly, I sin 5 pi by 6, we have I as it is here. Sin 5 pi by 6 is nothing but sin of pi minus pi by 6, which is plus sin by 6, which is 1 by 2. Sin pi by 6 is 1 by 2. So z to the power of 5 is minus root 3 by 2 plus I into 1 by 2. Next, let us consider I z to the power of 8. I into z to the power of 8 is nothing but I into e to the power of I into pi by 6, that is z is e to the power of I into pi by 6 whole to the power of 8, which is nothing but I into e to the power of I into 8 pi by 6. 8 pi by 6 is nothing but 4 pi by 3. And as we have seen, I is nothing but e to the power of I into pi by 2. Now upon simplification, that is a to the power of m into a to the power of n is a to the power of m plus n, which is nothing but e to the power of I into 11 pi by 6. Now next let us express this to polar form. We have cos 11 pi by 6 plus I sin 11 pi by 6. This is nothing but cos of 2 pi minus pi by 6. That is fourth quadrant. In fourth quadrant cos is positive. So cos of pi minus pi by 6, that is 11 pi by 6, is cos pi by 6. Cos pi by 6 is nothing but root 3 by 2 because cos is positive in fourth quadrant. Similarly, sin of 11 pi by 6 is nothing but sin of pi minus pi by 6, which is nothing but minus sin pi by 6, which is minus 1 by 2. Therefore, I z to the power of 8 in rectangular form or a plus ib form is root 3 by 2 minus I into 1 by 2. Next, let us take the base of this expression, that is 1 plus iz plus z to the power of 5 plus I z to the power of 8 whole to the power of 9. That is what we need to simplify. Now let us consider this base, that is 1 plus iz plus z to the power of 5 plus I into z to the power of 8. We have seen that z is e to the power of I into pi by 6 and iz is e to the power of I into 2 pi by 3. That is why instead of iz we are writing e to the power of I into 2 pi by 3. Similarly, z to the power of 5 here can be replaced by e to the power of I into 5 pi by 6, which we evaluated. Next, let us see what is iz to the power of 8 can be replaced with. It is e to the power of I into 11 pi by 6. So 1 plus iz plus z to the power of 5 plus iz to the power of 8 is equal to 1 plus e to the power of I into 2 pi by 3 plus e to the power of I into 5 pi by 6 plus e to the power of I into 11 pi by 6. We have seen that when we express this in rectangular form or a plus ib form, we have e to the power of I into 2 pi by 3 is minus 1 by 2 plus I into root 3 by 2, and e to the power of I into 5 pi by 6 is minus root 3 by 2 plus I into 1 by 2, and e to the power of I into 11 pi by 6 is root 3 by 2 minus I into 1 by 2. Now let us evaluate this, that is let us see what is the real and imaginary parts of this complex number. Now 1 plus iz plus z to the power of 5 plus I into z to the power of 8 becomes 1 by 2 plus I into root 3 by 2, because 1 minus 1 by 2, here we have 1 minus 1 by 2 is 1 by 2, and we have minus root 3 by 2 plus root 3 by 2 is eliminated. So real part of this complex number is 1 by 2. And let us see what is the imaginary part. It is I into root 3 by 2 here plus I into root 3 by 2, and we have plus I by 2 minus I by 2 is eliminated. So this expression is nothing but 1 by 2 plus I into root 3 by 2. When you express this in exponential form, this is nothing but e to the power of I into pi by 3, because you can see that polar form of this is cos pi by 3 plus I sin pi by 3. Cos pi by 3 is 1 by 2 and sin pi by 3 is root 3 by 2. In the exponential form it is e to the power of I into pi by 3. Now let us simplify this required expression, that is 1 plus iz plus z to the power of 5 plus iz to the power of 8 whole to the power of 9 is equal to, this expression is nothing but e to the power of I into pi by 3. I am substituting for the base here, that is e to the power of I into pi by 3 whole to the power of 9. Now a to the power of m whole to the power of n form, which will be e to the power of I into 9 pi by 3, which is e to the power of I into 3 pi. When you express this in polar form, it will be cos 3 pi plus I sin 3 pi. Cos 3 pi, odd multiples of cos theta is minus 1 and sin n pi is 0. Therefore, we have e to the power of I 3 pi is equal to, e to the power of I into 3 pi is equal to minus 1. So this is the required answer. So this complex expression of this complex number, that is 1 plus iz plus z to the power of 5 plus iz to the power of 8 whole to the power of 9 is reduced to a simple real number minus 1. If you enjoyed solving this, like the video, subscribe for more JEE math problems, comment below if you want more questions like this. Let's crack JEE one question at a time.